gets me concerned is you guys as seniors will make the same mistake as you did as freshmen in Algebra 1, and you will always, well no you won't always, but someone in this room on their midterm exam will forget to do both the positive and the negative case of absolute value, and they'll just solve it and get one solution. Okay? So, before we even get to the equation part, let's think about, well, what is absolute value? Because if we can wrap our brains around what is absolute value, then it kind of makes sense on why you need to have two separate cases when you're solving absolute value equations and inequalities. So, absolute value is the distance that a number is away from 0 on the number line. So if we're talking about distance, can distance ever be negative?
Never.
Never. Unless in the future we can go back in time and go backwards. But that's not happening right now. Okay? So, no matter if you're going in the negative direction of your number line or whether you're going in the positive direction of your number line, your distance is always going to be positive. Okay? So if you had something very basic such as the absolute value of x equals 4, well now let's think about this. What number has a distance of 4 units away from 0? Trevor?
4 and negative.
Good. So 1, 2, 3, 4. 4 is 1, 2, 3, 4 units away. But so is negative 4 is 1, 2, 3, 4 units away. So my solution set, so now we're back to equations. So now that means we're back to set notation. A set of numbers is going to be negative 4, comma 4. Which would be your solution. So the set of numbers of negative 4 and 4 would be solutions to that. Dylan.
Does it matter what order they're in?
You should put smallest to largest. I'm not going to probably take off if you don't, but you should. Unlike interval notation, where it does need to go left to right, solution sets, it's just a list of numbers. Okay? All right, so now let's make it a little bit more complicated. So now we have the absolute value of 2x plus 1 is equal to 7. Well, now it's not just what number has a distance of 7 away from 0. It's what number times 2 plus 1 has a distance of 7 from 0, right? But still the same thing holds true. I can go 7 units to the right of 0, and I can go 7 units to the left of 0, right? So just like the last example, my solutions were negative 4 and 4. Here, I'm going to have negative 7 and 7 for my units away from 0. So you're going to have both a positive and a negative case. My positive case, just drop your absolute value signs, which gives you 2x plus 1 equals 7. If we solve that out, we get 2x equals 6, x is equal to 3. But that only takes care of my movement to the right of 0. If we think about it as the real number line, I also have those 7 units to the left of 0, which means that 2x plus 1 could also equal negative 7. So now when you solve that side, we get 2x is equal to negative 8, x is equal to negative 4. Are my two numbers. So if I check it, 2 times 3 is 6, plus 1 is 7, the absolute value of 7 is 7. 2 times negative 4 is negative 8, plus 1 is negative 7, the absolute value of negative 7 is 7. So both of those numbers work. Guys, I'm about to break you up. Can you handle sitting next to each other or not? So smallest to largest, I have the set of -4 and 3. Okay, so absolute value, you always have two cases. You have the positive version, you have the negative version. Everyone always forgets this part. And if it's a 4-point problem, I'm only going to give you 1 point for doing this. I'm going to take away 3 points for not doing this because you don't have the concept of absolute value in your head. Okay? So make sure you remember the negative case. All right. Let's make it a little bit trickier, not too hard. Absolute value of x plus 3 plus 5 equals 12. The purpose of this example is to show you that before you can split it into your two separate cases, you need to get the absolute value part isolated by itself, meaning you can't have anything being multiplied in front of it, which in this case it's not. You can't have anything being added or subtracted behind it, which in this case you do. So before I can split it, I need to subtract the 5 first, which gets me the absolute value of x plus 3 is equal to 7. So now I can do, are we okay? Freddie, there was a face of,
I messed up, yeah. I get it.
you okay? So my positive case would be x plus 3 equals 7, which gets us x equals 4. My negative case, x plus 3 equals -7, which gets us -10. So it's the set of -10 and 4. Again, you should always be able to check it to make sure you're 100% correct. -10 plus 3 is -7. The absolute value of -7 is 7. 7 plus 5 is 12. 4 plus 3 is 7. The absolute value of 7 is 7. Plus 5 is 12. Okay? All right. So, absolute value. Before you split this, so do not do this. Ian, this is a common mistake. Students will do x plus 3 plus 5 equals 12. And then they'll do x plus 3 plus 5 equals -12. Oops. Got it right. And that's not right. Don't do that. Yes?
What decides which number goes first and then place one?
You go smallest to largest.
Thank you.
All right, so next type of problem that you will see on your homework is what happens if we get two sets of absolute value signs. So if you have something like this, the absolute value of ax plus b is equal to the absolute value of cx plus d. When you go to solve it, you're still going to keep in mind positive and negative cases. So, the positive case just eliminates absolute value, just like we did in the other problems. So it would just be ax plus b equals cx plus d. But the negative case, you have to take the negative of one, and only one, of the absolute values. I'm just always in the habit of picking the right side. It doesn't matter if you did the left side, you should still get the same answer. But this will still stay ax plus b, but now you have to take the negative of all the terms inside the right side absolute value equation sign. Okay, so you still have positive, negative, but now you're just going to take negative of multiple terms right here. Okay, so let's see what that looks like in action. We have the absolute value of z plus 6 equals the absolute value of 2z minus 3. So, positive case. I'll just eliminate all those absolute values. So, z plus 6 equals 2z minus 3. Solve it as normal. Subtract a z, subtract a z. 6 is equal to z minus 3. Adding 3 gets me 9 is equal to z. Now the negative case, left side still is going to stay z plus 6. Don't make that a negative. We have to make the right side negative. So you can either just make everything opposite in sign right away, which is what I tend to do. I'm going to write out the distribution. So it's the negative of 2z minus 3, which gets me z plus 6 equals negative 2z plus 3. Solving that, add 2z, so we get 3z is equal to negative 3 when you move the 6 over. Just did 2 steps in 1 step. Z is equal to negative 1. Let's check both, make sure we're good. 9 plus 6 is 15. 2 times 9 is 18. Minus 3 is 15, so that works. Negative 1 plus 6 is 5. 2 times negative 1 is negative 2 minus 3 is negative 5, but the absolute value of negative 5 is 5. So they both work. So we got negative 1 and 9 for my solution set. Okay? All right, so basic absolute value we've got. We've got double absolute value. So we've got 2 more things we've got to talk about, which are the 2 special cases. So we've got 2 special cases that deal with absolute value in equations. Special case number 1. These should be your favorites, the special cases. Here we have the absolute value of 5r minus 3 equals negative 4. Now remember, what did we say absolute value is? The distance that something is from 0. Will I ever have some number that can have a distance negative 4 units away from 0? No. So whenever you have absolute value equaling a negative number, you should have an internal hip hip hooray going on in your head, because it's going to just be a no solution. So that means no solving is involved. Okay? So make sure you pay attention to those. Now, if it said, I'm just going to use the same problem, if it would have said the absolute value of 5r minus 3 is equal to 0, this is special case number 2, well, what number is 0 units away from 0? 0, right? So there is no positive or negative of 0. So you just have the one case of 5r minus 3 is equal to 0. Which is what, 3/5 when you solve that out? So you're only going to have one solution when it's 0. Okay, so 2 cases. Negative should be our favorite because it's just no solution. If it's equal to 0, then you don't have both positive and negative. You just have the one case of it equaling it to 0. Okay? Questions with any of that? All right, that is all I have.